so for this final part of our notes of this section, we're going to be talking about if mass number is not the same as average atomic mass, remember mass number is calculated by protons plus neutrons, then what exactly is average atomic mass? And so we need to go ahead and define the average atomic mass as being a weighted average, which takes into account the number of each isotope found in nature. And so we're specifically going to be referring to average atomic mass as being a weighted average. And we're going to take a look at exactly how do we weight an average. All right, so going on to our next slide, or before we go on, this would be an example of lithium. Let me go back one here. This would be an example of lithium. In the case of lithium, we can have lithium being, I think it's approximately 94% of lithium being lithium-7 and approximately 6% of lithium being lithium-4. Okay, and so when we are talking about the weighted average, or how do we weight the average, we're going to take into account both how much, the percentage, and what those mass numbers are, what masses we are using. Okay, so the percent is the percent of each amount of each atom, and it is called a percent abundance. And that is one of your terms, percent abundance. And it's referring to this percent for how much of this element we find in nature. That is called the percent abundance. Okay, and we are going to have a method of calculating this. So to get our average atomic mass, in other words, the average atomic masses we find on the periodic table are calculated by taking the percent of each isotope and multiplying it by the average. So sorry, right in the middle of that conversation I was having with you, my phone went off, so I had to do something there. So now, the average atomic mass is going to be the percent abundance times the mass of each isotope, and we're going to add those all together. So literally, it is the percent of each isotope. So this would be percent of isotope number 1 times its mass, plus the percent of isotope number 2 times its mass. And if we had more than just those two, then we would keep on going with percent of isotope number 3 times its mass, and we would add all of these together. So in the next couple slides, you're going to see some examples of how to actually do these calculations for each type. So let's go ahead and move on to those. Okay, so in your notes, you should definitely have down that the atomic mass found on the periodic table is an average mass of all the isotopes of that element. Okay, this is the decimal number found on the periodic table. So this is the result of that calculation I was just referring to, and I am actually going to rewrite that calculation once again so that you can have it in your notes. So the average atomic mass can be calculated by taking the percent of isotope 1 multiplying by its mass, plus the percent of isotope 2 multiplied by its mass, and it would just continue going just like this. Now, something to keep in mind of all of your percents must be calculated in decimal form. So, for instance, decimal form would be if I have 90%, that is the same as saying 0.90. And that's what I mean by decimal form. So that's my example there. Okay, so this is not a terribly hard calculation, but it can become tedious if you have a lot of isotopes, because the more isotopes you have, the more times you have to do percent times mass and add that in. All right, so let's take a look at a couple of examples. Okay, so for this one, you can stop the video right now at this time and go ahead and add in, go ahead and watch this video. It gives you a good idea of what exactly is going on. And so we're going to go on to our next slide. And as you can see, this also, when you look at the video, you'll see that this is actually a summary of what the video was talking about. And ultimately, when you get this calculation done, you're doing the percent times the mass, and you're remembering to show your percent in decimal form so that you can do the calculations correctly. And then you're going to be adding up each of your results. Finally, your final answer needs to be rounded to 4 significant figures, so we should show this as 24.31 AMU. Okay, that is everything that you need to know about calculations, and you should be able to go on and finish the calculations on your own now. The final part here is for you to go update your personal word wall and do your calculations. Thank you, everybody.